In this video, I want to have a really quick look at a lot of facts about angles that you need to know to be able to solve problems. So what's really important when solving any of these problems in geometry is that you always give reasons for your answer. So whatever statement, mathematical statement that you make, you need to then in brackets put next to it the reason that you know that that statement's true. So sometimes it'll feel like you're stating the obvious, but you need to write it down. So the first angle fact that we need to know are complementary angles, and complementary angles are any angles that add up to 90 degrees. So for example, if we've got a right angle here, but it's split into two angles, then this angle here and this one here are complementary angles because together they make that 90-degree angle. So let's have a look at an example. We've got our right angle here, got another ray coming out, and we've got a 25-degree here and a theta here, and we want to find the size of that angle. Because we know they add up to 90 degrees, to find theta we can go 90 minus 25, and the reason for that is complementary angles. And then we can figure it out now that we've got our reason written down, and 90 minus 25 would give us 65 degrees. So theta is 65 degrees. So our next angle fact is supplementary angles add up to 180 degrees. So that means that they make a straight line. So if that's our straight line there, but it's made up of two angles, then this angle here and this angle here are supplementary angles. So if we have a look at an example, we've got our straight line here, we've got angles on here. This time it's going to be made up of three angles, but because they all still add together to give 180, they're still supplementary. So we've got this angle here is 85 degrees, we've got this one here is 50 degrees, and we've got our theta here that we're trying to find. So we're going to write down that theta, because it's a straight line, it's 180, so it's going to be 180 minus 85 minus 50 degrees. Now we need to put a reason in there, so we'd write supplementary angles. And we'll end up with 45 degrees. Next angle fact is that angles at a point add up to 360 degrees. So if we have a whole pile of rays coming off here, then those angles that are made up at the center, so that one, this one, and this one over here, they all add up to 360 degrees because when you put them together, they make up that full revolution. So let's have a look at an example. That's a 60 and 87 degrees. Let's make that one 100 degrees and this one theta. So to find theta, we'd have 360 degrees minus all the angles that we've already got. So we'd minus 100 degrees, minus 60 degrees, minus 87, and then we'd put our reason, which is angles at a point, and then we calculate that. Leaves us with, which leaves us with 113 degrees. Right, our next one is that vertically opposite angles are equal. So vertically opposite angles appear when you've got two straight lines that cross each other. So something like that. Then the angles that are opposite each other in that middle intersection are equal to each other. So that means that this angle here is exactly equal to this angle here. And it also means that this angle here is equal to this angle here. So this one, if we give an example, if we've got, say, 112 degrees here and theta here, then we just have that theta is equal to 112 degrees. And then, of course, you write your reason, which is vertically opposite. Okay, the last three angle facts that we want to look at are all to do with angles in parallel lines. So we've got alternate, corresponding, and co-interior angles. So if we have a look at alternate angles first, we know that alternate angles are always equal. So if we have two lines that are parallel and we've got a line crossing them, so the line that crosses straight over them, that's called a transversal, then alternate angles are, say, this one and this one. So they're both inside the parallel lines but on opposite sides of the transversal. The other pair of alternate angles is this one here and this one. So for example, if we had two parallel lines, had the transversal here. If we knew that this was 100 degrees and we had a theta here, then we could write theta is equal to 100 degrees, and we'd write alternate angles. Now, if we had a more specific diagram, if all our lines were labelled, so if we had, say, A, B, C, D, then we would write alternate angles and then comma, AB is parallel to CD. So to get more specific, we name the parallel lines because alternate angles are only equal if those lines are parallel. All right, our next ones are corresponding angles are equal. So again, we've got our parallel lines, we've got a transversal cutting them. Corresponding angles are, for example, this one here and this one here. So one of those angles is going to be inside the parallel lines, one's going to be outside, but they're both going to be on the same side of the transversal. So it kind of looks like that angle's just been slid down on top of that one. So we've got a couple of other pairs in there. We've got this one here and this one here. We've got this angle and this one are corresponding, and we've also got this angle and this angle are corresponding. So there's 4 pairs of corresponding angles. All right, so if we have a look, we've got 2 parallel lines. We've got a transversal going across there. If we know that this is 120 degrees and we've got theta there, let's label our parallel lines again. So A, B, C, D. So we could write theta is equal to 120 degrees. And then our reason would be corresponding angles. And then AB is parallel to CD. Okay, our last set of angles in parallel lines are what's called co-interior angles. And co-interior angles are supplementary. So if we have our 2 parallel lines, we've got our transversal. There's 2 set pairs of co-interior angles. One is this one here and this one here. And I've used different symbols this time because they're not the same size. They're supplementary, which means this angle and this one add up to 180. The other pair there is this one and this one. So they're both inside the parallel lines and they're on the same side of the transversal. All right, so if we have a look at one last example, we've got our parallel lines. We know that this here is 50 degrees and we've got a theta up here. We can write theta is equal to 180 degrees minus 50, and we write co-interior angles. Again, if we knew what the parallel lines were called, we'd name them as well. So co-interior angles, and then our answer would be 130 degrees. So that's just a really brief overview of a lot of the angle facts that you need to be familiar with and be able to recognize in problems. But the main point to take away from this video is that every time you answer a question, even if you feel like you're stating the obvious, you need to give a reason to back up what you're doing.